We are delighted to have with us Stavros Papadopoulos to talk to us about a very interesting new approach to databases that I hope will be of interest and benefit to many of you, especially the ones who are, I know, working with matrix calculations for various things, among other things, databases and logic. So without further ado, Stavros, I think you can say more about yourself and the company and the database. TileDB.
Absolutely. Thank you, George, and thank you everyone for attending and giving us your time and the opportunity to present all the work we've been doing with TileDB. Of course, I'm going to dive deeper into it and give you a little bit of background. And so I'm going to spend about 15 minutes on a slide deck, just giving you the context around TileDB, and then Seth, my colleague, who is also our CTO, is going to give you a demo, so that we make it much more practical and you guys can get a much better look into our technology. All right. So first of all, TileDB used to be a research project when I was at Intel and MIT several years back. It came out of a research paper that we wrote. We've been doing a lot of research around, well, coincidentally, machine learning and high performance computing. And we realized that the commercial database, and of course, I'm a database guy, that has always been my research background. We realized very early on that databases are not very good at machine learning. And the reason is that tables are not first-class citizens in machine learning. Now, of course, there is a huge hype around AI. This kind of forces us to position our database as a database for AI. There is a reason why we call it like that. And I'm going to explain what it means to be an AI native database. A lot of systems out there are claiming that they're platforms for AI or that they're AI native. So I'm going hopefully to clarify exactly what it means to be AI native and why we believe that TileDB stands very good chances at winning the mind share of people around data management for AI. But this is where it started. I spun it out of Intel and MIT in 2017. Since then, we grew the company. I started as a single person. Seth joined me very quickly after that, and we've been running the company for quite some time now. We're almost 70 people and growing. We've raised over $50 million in VC capital and strategic, also VC capital. We're working almost exclusively with large organizations, at least at this stage, as we grow and as we build the product. The product is very sophisticated. It takes many, many years to build. We're building it from the ground up. We make no discounts on the quality and on the fundamentals behind this database. So that unfortunately makes us move a little bit more cautiously, but we have amazing proof points with all those big organizations we're working with. And now the product has become quite mature, and we can't wait to show you all the features and see how we can help organizations like Democritus. We believe from the initial discussions that we've had that this can be a very, very powerful tool for your research. All right, so here's the problem we're seeing across the board. This hopefully can resonate a little bit with Democritus, and I'm eager to get your feedback. But we're seeing this across multiple different disciplines, not only machine learning, not only AI, not only life sciences, not only geospatial, but pretty much everybody. So everybody is trying to build an AI infrastructure. It's all around data. If you want to do AI, you need to have some very solid data stack in place. Otherwise, everything is going to collapse. And also, it's not only AI. AI is always a good holy grail to pursue because it can be beneficial to your organization. But even before you get to the AI functionality, you still need the data stack because the data could be diverse, the data could be difficult to tame, and at the end of the day, you're unlocking insights from the data itself. So don't think that TileDB is only used for AI. It's just that it is an amazing candidate when you're building AI infrastructure. And a lot of things I'm going to present on this slide exist even beyond AI. So what do you usually build, or what do usually organizations build when they're building infrastructure? So it could be data warehousing. Actually, this is perhaps the first thing they're starting with, and it's not the most useful, but they are starting from this. And then they have ETL and pipelines. And then they have what they call unstructured data. We avoid using this term because I'm going to tell you very soon that nothing is unstructured in TileDB. But yeah, if you're using a tabular database, of course, an image is going to look unstructured to you. But that's not the case with TileDB. So you have a lot of additional diverse data. And then you have the scientific data. If you do anything with simulations and anything in the scientific domain, you're not using tables, you're using arrays. Of course, you're starting injecting AI and ML, and that could be vector search, could be LLMs, it could be machine learning, it could be computer vision, right? Could be something more traditional. And then you have the applications, because on top of the data, you need Jupyter notebooks, you need dashboards, you need web apps. You, of course, need files because some of the data is in formats that other databases cannot handle, or you just have plain files like docs and PDFs and others. On top of everything, you're going to be able to manage your code. So you're using GitHub or GitLab or Hugging Face or something else. And last but not least, you need also some domain-specific solutions, right? For life sciences, you may have genomics and VCF data and BAM files and whatnot. In geospatial, you have TIFFs and you may have geometries. And I can go on and on. Like as you go deeper into the domains, the data becomes even more specialized. And on top of everything, you need to catalog everything, right? You need to be able to discover things. You need to govern the data, because either you have sensitive data and you need to protect it, or you just need to be able to share it and collaborate easily with others without losing track of where the data is and what you're doing with the data and so on and so forth. And the problem, unfortunately, is that this data looks so disconnected and so disconcerted. I mentioned files, I mentioned VCF, I mentioned tables, I mentioned video, audio. These look very, very different. So you need to reason differently when you deal with this data, and this creates a lot of problems. And finally, in order to be able to do this and to build this infrastructure, even if you use 10 amazing products, you need to put a lot of effort in data engineering. And usually in organizations like yours, they want to do science. They want to get to the data they're going to get to the insights very, very fast. Data engineering is a necessary evil because of all these problems that I mentioned. So this is the landscape. This is pretty much what organizations are dealing with. And again, it doesn't matter what vertical you're in. It doesn't matter what application you're in. So what is TileDB? TileDB is a one-stop shop, an all-in-one solution for all of this. So believe it or not, TileDB is so powerful that it can do all of this, everything I mentioned, in a single product, and actually a database. I don't want to call it a platform. Platforms are very, very different. Platforms is in their biggest generality, they're an aggregate of disconcerted systems. TileDB is a single product built from the ground up, and I'm going to tell you the secret sauce, all the superpowers of TileDB and how we pull it off. But it is a single product that allows you to do all of these things under a unified data model with catalogs and strict governance and zero maintenance, because it's a database. Like, you just use it. You don't need to do any data engineering on top. So the demo that Seth is going to show you, of course, is going to touch upon most of this stuff. But if we missed anything during the demo, we can schedule more demos. We can send you more materials and so on and so forth. All right, so how can we do this, right? This sounds too good to be true. These are disconcerting things. How can a single product pull it off? So TileDB started with a very simple observation. The observation is that you can put together some carefully designed foundations, some primitives, and build upon those to capture pretty much everything. Everything that has to do with AI infrastructure or with complex data analytics. So what are these foundations? The number one foundation is the multidimensional array as a first-class citizen in TileDB. So I'm gonna show you another slide about what arrays can do, but there is a misconception that we're trying very hard to eliminate, which is, arrays are great only for linear algebra and for some parts of machine learning. This is very true. They're extremely powerful. But one thing that you might not know, and we can prove even mathematically now, is that the array model subsumes the relational model. This means that we can do everything that the tabular database can do. And actually, because of the way we engineered arrays, we can be faster. We can be faster than Snowflake. We can be faster than any database, for that matter, than any tabular database. And it's the way we store the data and the way we process the data with those arrays, with those multidimensional objects. So when I talk about arrays, don't rush to name us a niche. We are the generalization of relational databases. That's how you should be thinking about us. But on top of this, and because of the fact we can do tables and beyond, we can structure what other people think is unstructured. A video is an array. An image is an array. Key value pairs are arrays. Vectors, by definition, are one-dimensional arrays. And I can go on and on and on. So this is a huge, huge, magical superpower that TileDB has that allows us to do stuff that other databases cannot do. The other thing that we do is that we put a lot of emphasis on the coding part, right? We have user-defined functions, task graphs. Now there are some amazing upcoming features on integrating directly with GitHub and GitLab and Hugging Face so that you keep the code alongside your data and manage it in a single solution. You should not put your data in a completely different solution from the data that this code is touching on. It should be categorized. It should be grouped with the data, access control with the data, logged with the data. And Seth is going to show you how we do this today. It's extremely powerful. It's as simple as creating a virtual directory, putting a data set in it, putting all your code, like a user-defined function, some pipelines, a dashboard, all of it. It's a machine learning model in that group. And then you have a single object to log and access control by sharing it safely with other collaborators and seeing the lineage, seeing the versioning, seeing the time traveling and all of that stuff. This becomes very, very powerful. The other thing that we did is that we exposed the computational infrastructure. So we built it serverless, we built it elastic, it's distributed, but we expose it. We don't just give you a language like SQL and we say, you can only interface with the database with SQL. We give you access to the primitives. You have a bunch of workers, as many as you want. Again, everything is serverless. You can run any piece of code on any node, and you can define dependencies through task graphs, effectively creating all the pipelines or distributed algorithms, pretty much anything under the sun, without having to think about, oh my goodness, I need to procure EC2 instances on Amazon, and I need to monitor them. And if they go down, I need to go and stand them up again, and so on and so forth. Everything's automatic. And it's part of the database. We believe that an evolved database should have code and compute as part of the data. They should not be different systems. It should be part of the database. And last but not least, everything around governance. We are SOC 2 compliant. Most of our customers have sensitive data we're working with. AstraZeneca, we're working with Lockheed Martin. Those guys take privacy and security of their data extremely seriously, and so do we. So these primitives allow us to take the database to a different level than anybody else out there. So a little bit more drilling down into arrays. As we say, no data is unstructured for us, because the way people were thinking about data structures was as follows. They were saying, you know what, we're going to get married to tables. Tables is our first-class citizen, and we will try to overfit any other data type into a table. A table can handle table. I don't know why this happened. Can you guys see this? For some reason, the sharing stopped. Can you see this?
Yeah.
Yes, you can.
Okay, thanks. All right, sorry about that. So as I was saying, usually people are saying, I'm going to use a table, and then if it is an image, I need to fit it into the table somehow. Like I'm going to chunk it, I'm going to create blobs, right? I'm going to create a column, which is the blob. I'm going to put it there, or I'm going to put a link to the actual file, which lives elsewhere. And the reason is that the table is stiff. Arrays take a completely different approach. They're this very fluid data structure that shapeshifts and becomes the data. It becomes a table. It becomes an image. It becomes a graph. Effectively, it can become anything. It can become three-dimensional points in space. It can become time series. It can become microscopy imaging. It can become vectors, vector embeddings. It can become an actual graph. The graph is an adjacency matrix, right? And we built an amazing data format and an engine on top, which is, you can think of it as, I don't know, Parquet on steroids or HTF5 on steroids. It combines the benefits of Parquet alongside the benefits of HTF5 and other high-performance computing formats, all in one. You don't need to have a different format for tables, a different format for images, a different format for genomics, a different format for imaging. You can have a single format that just shapeshifts and captures everything at once. This is very, very powerful. All right, specifically for Gen AI, there is huge hype around, LLMs and vectors and everything. Well, TileDB, especially because of this shape-shifting ability of arrays, it was extremely easy for us to react to what the market needed around vector embeddings and integrations with LLMs. And we can prove that TileDB is like, think of it as the OG, the original gangster of vectors and vector embeddings and LLMs, only because it's our natural format, right? So effectively what happens, and we are seeing more and more applications around that, is that you have all this diverse data, could be files, could be images, could be tables, could be anything. And of course, the applications querying them. And they're all fed into an embedding model. Seth is going to show you that we're even storing the embedding model as part of the database, and we're training it, and we're serving it inside the database. And this is producing those vectors, those embeddings. These are one-dimensional arrays. Those are grouped together into a vector database, which again, it's just an array with some indexes. And we integrate with the LLMs. We put all of this on object stores because it's much more, it's very efficient, but also very economical, and everything is cost effective. And you can have this solution and this Gen AI feature as part of the same database. You don't need another database and another system to host your LLMs and so on and so forth in order to introduce Gen AI capabilities to your stack. So everything is in a single product. So we've proven this with multiple amazing customers and in amazing verticals. So life sciences and geospatial are where TileDB shines only because they're extremely difficult to handle, very complex data, huge data, so very diverse data. And TileDB is extremely good at this. We have amazing expertise when it comes to working with big organizations. We give them a lot of support. Of course, the database scales massively. And of course, all of those guys can act as referees for what we're doing. A little bit into the architecture, and again, Seth is going to show you more. At the very bottom, you can store the data anywhere you want. TileDB is super optimized for the cloud, but also super optimized for HPC settings as well. And please note that you always own your data. Your data is stored in the TileDB open source format. We never host, especially in our SaaS. I'm going to tell you very soon that TileDB can be deployed in SaaS, but also can be self-hosted. In either case, you own your data. You bring your own buckets. We don't store the data ourselves. This gives you, much less vendor lock-in. You can stop the services, and there are all these libraries that can access all the data even beyond the product. Now, on top of everything we do, we have built amazing integrations and amazing APIs that can access your data in multiple different forms. We have native support. And again, we are an AI native database for PyTorch and TensorFlow. This means that PyTorch and TensorFlow speak TileDB. We don't convert the data into TF records and then feed the data into PyTorch, for example, so that you can run some models. PyTorch speaks TileDB. Everything is logged. Everything is access controlled through these integrations. And we have multiple APIs. You can work in Python. You can work in R without converting data back and forth. We have a lot of SQL support. We have a lot of domain-specific applications and integrations. So we are very, very big in interoperability. And then TileDB Cloud is the actual commercial product. This is a full-fledged database with access control, the security, the distributed computing, the Jupyter notebooks, and this is what Seth is going to show you. But at the core of it, there is a huge open source ecosystem of TileDB that interoperates even with this top part that you see here. It doesn't have the database features like, again, authentication, access control, logging, sharing, distributed computing, but still it can give you value, and all the data you're producing is accessible by the open source ecosystem. So as a takeaway, the reason why organizations are working with us is, bluntly speaking, they save a ton when it comes to this data infrastructure. We say 90% here, it could be more. We can replace tens of solutions with one database. Because of the way TileDB works on the cloud with spot instances and optimizations, we reduce significantly the compute consumption on top of everything. And also there are intangibles, right? We eliminate the silos, so the productivity increases. Your different departments don't need to purchase different systems. They can work on the same, and they can have secure access to each other's data. And we increase significantly the productivity, right? This is also money. You can get to insights faster, you can collaborate faster, you can reproduce your experiments faster. So this translates to money savings for your organization. So that's it from me. Seth will show you some more practical aspects of the system. I'm happy to answer any quick questions now. And then we can just move forward with a demo. We can answer more questions then.
I would also say that anybody who has any questions, they can also write them in the chat, and then we can collect them so that we don't waste time from Seth's demo.
All right, with that, I will share my screen and I will get started. All right. So what I'm going to be walking you through today is the TileDB Cloud web interface and a little bit of programmatic access and some hosted applications that we have in the system. Everything I'm going to be showing you is from the TileDB Cloud SaaS version. All of this will be public examples that we can send over, public data sets and dashboards. But all of the features that I'm going to show you are also available to be hosted on-prem or in your own VPC and cloud environment, so you can self-host everything. Also, everything has APIs behind it. So no matter what I'm going to show you, whether it's the catalog functionality I'm on now, whether it's some of the computations or the data access, every single thing has programmatic access in a variety of languages. So we support things like Python and Java and R and C# and SQL and many other ways to access the data and perform different functionality. So you have a lot of flexibility in how you use TileDB and how you build on top of it and how you integrate it into your existing workflows and applications. The first thing that I want to walk through is a little bit of the catalog and data management aspects. As Stavros mentioned, TileDB is very flexible, and we have a lot of different modalities of data that we've brought into the system here. And we've called out some of these at a very high level right away. And I want to walk through a couple use cases and a couple examples of that. Then starting off with one really good one is images. Images are something that you can't store in traditional SQL databases, and you end up with a file management nightmare storing them as simple files and object stores. But here in TileDB, we can actually store a multidimensional, we can store an image as a multidimensional array, and you get a lot of flexibility and power. So we've got images called directly out here in TileDB Cloud. We've got a couple different examples like biomedical imaging. And if I open up one of our biomedical images, you can see a wide variety of details right off the bat. We have a markdown description where you can explain in human readable terms, what is this data set? You can embed text, tables, images, what have you. Think of this like a README for your data itself. You can see overview information such as the permissions that you have in for this data set in TileDB Cloud. Everything in TileDB Cloud is role-based permissions. This means that depending on your permissions in the organization, your level in the organization, or your role inside an org, depends on what you can do with the data and what you can access with it. Here, I'm an administrator, so I have full permissions to the entire data set. And this means I can even see some sensitive things like the actual storage location. All of the data that I'm going to be showing you today is going to live on S3. So the data can be stored on object stores like S3. Again, if you self-host this on Azure or in your own cloud environments, you have flexibility where it is. But TileDB is cloud native, so we work really, really well with object stores. But one of the important things is that as an administrator, I can see all the details about the storage. But as a user, I don't need to worry about where data is physically stored. I don't need to worry about what cloud provider, what bucket it's in. I don't have to call up IT and say, hey, can you get me access to this S3 bucket where it's stored? Instead, all access goes through the TileDB URI and through TileDB Cloud, where you're authenticated, access controlled, and audit log directly in the system here. So this makes it very, very simple for you to come in and manage your data across all different modalities, across multiple storage backends, different cloud vendors, all in one system without having to worry about direct physical access to the underlying data. We abstract it all away from you. TileDB also supports, of course, things like single sign-on providers, importing organizations and hierarchies from things like Active Directory, Okta, LDAP, and what have you. So when you talk about data management, you can tie this directly to organizational management. You can tie what permissions that you have based off, what role you have inside the organization and what data you have access to based off, again, what role you have in the organization. We also support a lot of data management across geographic boundaries. So if you have data in different geographic regions with different constraints, maybe there's data inside the EU, and then maybe there's some data in say England, which now has some different rules and regulations. You can support permissions and granularity across different data sets depending on where they're stored, so you can manage compliance very easily. So in addition to the overview, we provide a lot of other details directly in TileDB Cloud, including things like metadata. You can attach any type of arbitrary key value metadata to any data set. So this means that you can come in here and you can attach things like vendor ID, project IDs. You can see entire, large JSON details about this image here, channels, metadata. Anything you'd like can be attached here, and this is all cataloged and globally searchable. So if you have things like project IDs, you can put metadata tags. You can then come into the catalog functionality and globally search for any data set that I have access to for project 123, or that has a certain set of metadata tags, maybe a vendor tag and a QA tag and a department tag, what have you. So the metadata is stored directly attached to the data sets, and it's cataloged and globally searchable. So you can have all of the metadata in the database itself, and you can search and find your data sets based off that too. Of course, if you're going to be collaborating with third parties, you need the ability to very easily share your data and manage permissions across different teams and different organizations. So we make it as easy as using something like Google Docs to come in here and share this data set. So if I want to share it with Stavros, I can, for instance, type Stavros, select his name. I can select permissions, read plus write, what have you. And with one click, I could share the data. With one click, I can also revoke access. You can also, of course, do this programmatically. So this means that I don't have to worry about downloading this image to my laptop, sending it to Stavros via email or via Microsoft Teams. The same thing works for any data set. You could have terabytes of data, of tabular data, terabytes of genetic data, or of scientific data, of machine learning models. Every single part of the database has one-click sharing capabilities. So this means that you can centralize management of everything in one location without having to worry about people creating copies or duplicating data, or going through the classic problem of when you have 5 copies of a data set, you don't know which one's the real deal and which one's the final version. Instead, in TileDB, there lives one version of every data set with centralized governance and access control. And of course, if you're going to be sharing with third parties, you need to be able to see activity logs. Who's been accessing the data and what have they been doing? So you can see that I accessed some of this data sets just a little bit earlier. And you can see high level information. I performed a read operation on this image. I read some of the schema details. And if I actually click through, you can see specific details. So this is an image, right? So here I can see what channels did I access, RGBA. What X and Y bound? So what part of the image was I actually accessing? So I was accessing just one particular section of the image here. So you can see contextualized information. It doesn't just say that I accessed an image stored on an object store. It tells me exactly the parts of the image that I accessed. And of course, you see statistics and timers, so you can understand hotspots and performance and all of those details directly in the TileDB Cloud system. And not only do you have the ability to view specifics about the data, but the entire workflow that you run is logged directly in TileDB Cloud. So here's an example of a workflow on images that I ran, and if there's time, I'll run through this live for everyone here, where I was running some machine learning models across a bunch of images. And here you can see the entire summary of the entire pipeline that I ran, the task graph that I ran, the cost. In SaaS, there's cost associated with things. You can see that right here clearly. The time and duration it took to run the ML algorithm across all of the images. You can come in and see the breakdowns of specific tasks that were run inside this task graph. So here is one Python function that I ran. It used 6 CPUs with 24 gigs of RAM. And if I click through, I can actually see the specific details. You know, it was 54 seconds. It's a Python function. I get to see the entire Python function here. I can also see any logs, standard error, standard out, output in the system. So not only do you have access to the data and the logs of the data access, but you actually have access to the Python functions, to the SQL queries, to any type of computation that's run through the system. So not only do you know who's accessing what data, but you know exactly what they're doing on the data, what machine learning models are running, what Python functions, what R functions, what SQL queries. Everything in the system is logged directly here in TileDB Cloud. Now, one of the really cool things too that we have here in TileDB Cloud is the ability for different data sets to actually come in and preview them live. So because this is an image, I can actually come in and I can view the image live without having to download it and open it on my laptop or use an external software. I can just come in and see, okay, what is this cancer image of a cell here? I can see it. I can zoom in. I can pan. I can zoom. We can see higher and higher resolutions loading as I'm zooming in. And again, what's happening right now as I'm viewing this image? I'm on my laptop connected to Wi-Fi. I'm talking across the internet to the TileDB Cloud service. I'm authenticated. I'm access controlled. It's audit logged. The data of this image is stored in TileDB. It lives on Amazon S3 in an object store. So across the internet, I'm talking to the TileDB Cloud service. It's then accessing the image in the TileDB form on an object store in real time, logging everything, and then returning only the bounds of what I'm accessing here. So this gives TileDB a lot of capabilities. We can run large-scale analysis, but we can also run things with real-time capabilities. I can preview an image here live. I can pan, I can zoom, and you can see it loading the different parts of the image on the fly here as I go. This same exact thing works for a wide variety of our assets that we have in the system. Another great example is when we store three-dimensional point clouds. So here's one of our examples where, of the Alton Stadium in Oregon, where you're going to see all the same basic details. Now, this is a completely different data type and data set, but you see the same basic details: description, metadata, sharing, activity. And if I preview this, we can actually see a 3D rendering right here in my browser of the football stadium in Alton. So here I can pan, I can zoom. You can see the points moving in. If I zoom in, we see eventually the points break down, and if I zoom out, we get the whole picture here. And again, all of these is stored on an Amazon object store, going through the TileDB Cloud service, authenticated, access control, audit logged across the internet to my laptop, and then back across Zoom to you guys. So you see, there's a lot of real-time capabilities that TileDB has directly in the system here. All right. So in addition to the data sets itself, like images, like point clouds, like tabular data. We've got tabular data sets here. TileDB can also store a number of other modalities, including things like arbitrary files. So when we talk about TileDB supporting a multimodal database and bringing all these different data sets together, we wanted to bring every type of data, even things like arbitrary files, into the database where you can process them, you can parse them, you can control access to them, and you have the same audit log capabilities in the system. So here's an example of a PDF that we have that we've loaded directly into TileDB here, and I can preview it. And again, you're going to see it looks just like a normal PDF. This is actually a paper that was published with Rady Children's Hospital in San Diego, a customer and collaborator of ours, where we are working on a whole newborn screening project. This paper was published, and we've loaded it into TileDB here. And it looks like a normal PDF that you'd fetch from any random site, but it's actually stored in TileDB with access control, audit log, authentication in the same database where I'm storing the images, where I just stored the point clouds, where I've got a bunch of tabular data sets stored right here. And of course, you got the same basic details like sharing, activity, metadata, all directly in the system here. One additional thing I want to point out too is that this versioning support. So TileDB actually lets you have the ability to time travel and keep track of versions over any asset in the system. So whether it's the data, whether it's files, whether it's machine learning models, everything has versioning attached to it. So this means that as you're updating your data sets over time, new data is coming in every day, every hour, every minute, all the versions are tracked in the system. So when you are running analysis or you're running a machine learning pipeline, you can go back in time and you can see what it was like. So if I train a machine learning model on a particular set of data, as it was, say, today on March 11th, in 6 months, I can actually go back and say, you know what, I want to see what the data was like on March 11th. I can open up any data set and I can say, show me the data set as it looked like on March 11th. I can run a machine learning model as it was on a particular point in time. So if I'm updating machine learning models over time, retraining them, I can A/B test easily. I can go back and forth. So everything in TileDB Cloud has versions attached to it. And speaking of machine learning models, TileDB brings multiple integrations on the machine learning side, and we'll actually run a couple examples of this live in just a moment. But I want to start off with talking about the model registry. So we have integrations for data access and for model registry. So of course, if you're going to be storing machine learning models, you need to catalog them. They need to be indexed. You need to be able to find and search them, and you need to be able to share them. So TileDB brings all of that reproducibility directly here in TileDB Cloud by the ability to store any type of machine learning model, a PyTorch model, a TensorFlow model, a sklearn model, other frameworks directly in TileDB, where you have all of the governance and access control. So here's a variety of our models that we have, and here's actually an edge detection model for the images, which again, we'll run through in just a moment here. And you can see again a lot of the same basic details that we've been looking at, things like the storage location, the permissions that you have, the description, but we also highlight some specific details relevant to each of the different asset types. So for a machine learning model, it's very important for you to understand what framework was it made with, what Python version was it made with. If I go to the preview, I can see actually details about the machine learning model. Here it's a network. If it was an SVM or a linear regression, I'd see other pieces of information here. And again, we have the versioning built directly into the system here where you can track different versions of the model over time. So we make sure that you have the full capabilities needed to really power your AI and your ML aspects by storing the models directly here in TileDB Cloud. And then of course, being able to run these models over top of your data sets. I also want to highlight that TileDB lets you store not just machine learning models, but the actual functions and entire workflows. So as an example here, here's one of our functions that we have registered directly in TileDB Cloud, where again, you have all the same basic details we've been talking about. But if I preview this, I can actually see the actual Python code of this function. So not only can you store your models and your data and your files, but we can actually store the actual code itself directly in TileDB too. So we take any user-defined function, Python, R, store it directly in the TileDB Cloud system here. You can preview the whole details, and then you can simply indicate this function by name. And there's some really powerful things that come from this. First off, you have reproducibility. Everybody with permissions has access to the same version of the function. And of course, there's versions over time. So you can see updates, you can see different versions as you go. You can call particular versions of a function. So if you're running an analysis on a version of the function from March 21st, you can use that. If you update it, the version, and there's a new one in April, you can specify which version of the function you want to run. So you can keep running the same production workflows without worrying about things changing underneath you. You also have the capabilities of calling registered functions or registered task graphs from different languages. So this is a Python function here, but I could actually call this Python function directly from JavaScript because the Python code is stored in the TileDB Cloud system. I don't need that locally. So from a web front end, I can call entire workflows in different languages. I can mix and match languages. I can have Python and R and SQL all mixed together, and you can build entire complex workflows directly in TileDB Cloud. And as I mentioned, you can also register entire workflows. So here's an example of one of our genomic workflows where, again, everything has the same basic functionality around access control, audit logs, descriptions, sharing capabilities. And if I preview this, we'll see the entire workflow. It looks a little complex, but that's kind of the point where I can store complex pipelines that have many different inputs and outputs. They can be registered in the system. Each one of these is different functions. Some are SQL, some are Python. And I can actually call this function by name. So again, from this Python and SQL mixture, from R, from Java, from JavaScript, from a web front end that I'm building. I can actually call an entire pipeline and then get the results back. So this gives you a lot of flexibility of registering everything in one database, one centralized access control, one place for audit logs, one place to manage all of the end-to-end reproducibility aspects of the code, the data, the machine learning models, everything together in one environment. Now, let's bring this together with a couple high-level example applications. So we'll run some code in just a moment, but I want to start by showing a few high-level applications that you can build directly on top of TileDB. So with the data that we have in the system, with machine learning models that we have in the system, and with the computation capabilities that TileDB offers, you can build end-to-end applications such as private chatbots. So here's a chatbot that I have. I've already asked it one question here. What is Begins? Begins is a consortium that focuses on newborn sequencing. So Begins here, this is the research paper that I just showed you a moment ago, that PDF example that I have. I have used that to power my chatbot. So let me explain a little bit about what happens here. So this chatbot is using OpenAI and ChatGPT. ChatGPT, though, it's trained on the internet, right? It's got a lot of data and information in it, but it doesn't have my private data. It doesn't have my updated information. ChatGPT doesn't know about the Rady paper, the paper that was published in collaboration of TileDB and Rady Children's Hospital. It doesn't know about my private documents. So what we have done is we've taken that PDF that's stored in the TileDB system, we've produced a vector search data set from it, and we augment ChatGPT with a RAG style setup to give it the extra information from my private documents so it can answer questions in natural language. And here I can ask it a question live. How does Begin store its VCF files? Again, this is a genomics project that we do with Rady Children's Hospital. So when I submit this question to ChatGPT, what's happening is it parses our embeddings that we have stored in TileDB, the embeddings we've produced from the PDF document. It fetches the top results. It sends that part of the document and those embeddings to OpenAI. OpenAI then it augments ChatGPT's knowledge with my private document details, and it gives me a response back here in natural language. So I can augment things like ChatGPT directly with my private data. This also works for self-hosted LLM. So if you don't want to use OpenAI, if you want to use Llama 2 or Falcon or other self-hosted LLMs, you have a lot of flexibility. But a lot of folks like ChatGPT, so we have the ability to integrate directly with it and take the private data that's stored in TileDB, that PDF that I showed you a moment ago. And actually, I can pull that PDF back up here. This PDF, again, it's a paper that was published last year. ChatGPT doesn't know about it. We have parsed this PDF. We've produced embeddings about it. It's stored in authenticated access control auto log directly in TileDB. And we can use this private documents that we have to augment ChatGPT and answer questions in natural language. And this works for any number of documents. So we've got a variety of different data sets that I've preloaded directly here in the system. We have, you can have several different knowledge bases. So you can have one giant knowledge base. You can segment your knowledge bases by department, by regulations or authentication. Here, I've got a couple different vector search data sets that can be used directly in the system. And of course, you can do more than just natural language. So natural language and ChatGPT is one very common way of accessing data. But say you had images. We'll go back to that image example for a moment. We can also support integrations with machine learning models, producing embeddings on images, and ask the same type of natural language questions on images. So if I upload an image from my laptop, what's happening right now is this image is uploaded to my dashboard here. Embeddings of that image are produced on the fly. We then perform a vector search query behind the scenes here to find similar images inside my entire corpus of images. So we've loaded a few thousand images of plants in this example. And I take my image, the dashboard here then takes the image from my laptop, finds the three most similar images and returns them to me. And the important thing to understand here is that TileDB not only stores the vectors, but it also stores the raw data itself. So whether you're using documents, whether you're using images, whether you have genetic data, whether you have scientific data, whether you have tables and tabular data sets, TileDB stores the tables and the embeddings and the vectors all in one system. This way you can access end-to-end pipelines and end-to-end functionality of not just saying, I have an image, tell me which image it is. knowing that it's image 57 doesn't do you anything. You need to actually see the image. You need to be able to download the image. And so TileDB brings all of that in one centralized platform here. Okay, so in addition to the vector search, TileDB also has a lot of other capabilities for dashboards. We can have low-code environments where you can build basic tabular style lookups. So here's actually accessing some genetic variant data where I can come in. I can have a couple different parameters. I can autocomplete things like you can have autocomplete in here. So you can build entire fully functional business intelligence and business analytic dashboards or workflows for scientific use cases. Here, I can submit a query, and what happens right here, right? Boom, in a completely distributed serverless manner. As an end user, I have a dashboard, but I'm accessing an entire genetic data set. This data set's about 11 terabytes in total behind the scenes. So an 11 terabyte data set that lives on Amazon S3. Again, from my browser here, I have a dashboard with a couple of parameters. I click submit. We access that 11 terabytes of data. Only the relevant information that matches my query, females from Great Britain that have BRCA1 mutations. The results are fetched, returned, and printed out for me here. So I don't have to download 11 terabytes. I didn't have to wait minutes to search that entire 11 terabytes. TileDB is super efficient at retrieving the exact information that's required from large corpuses of data so that you can do near real-time or real-time analysis directly in the system. We also have the capabilities of integrating with a lot of different dashboards and functionality. So here is an example of one of our Shiny dashboards where you can come in, you can have all the different details, the plots, the widgets, the information. So we can build Python dashboards, Shiny dashboards, Boca, Dash. I mean, we got a lot of different capabilities supporting building dashboards on top of TileDB and hosting them directly in TileDB Cloud. Again, an example here is this is an Shiny dashboard, but it's running in the TileDB Cloud system. I'm not running separate infrastructure. A lot of times when people build like Shiny apps or Flask apps or other types of web front ends, you need to host your own server. You need to put it behind authentication, access control, hook it up to LDAP and AD and things like that. Instead, you can run dashboards directly in TileDB Cloud. The infrastructure is managed by TileDB. We're running the servers behind the scenes. The TileDB Cloud system is running the servers. I'm authenticated because I'm logged into the website. So we know who I am. The data that I have access and the dashboards that I have access all come from authentication access control of me being in the system. So you don't have to run a completely separate infrastructure. You can actually host the application directly in the database. And again, we're designed to be cloud native, so everything scales out. So the more data I'm accessing, the more users you have in the system, the more applications things are running. The backend just scales elastically up and down based off demand. We also have a lot of integrations with things like mapping. So we can do integrations like Mapbox with vector tile servers here, where you can pan and zoom. You can load things, so you can have overlays like Google Maps and all. And we can also do things like SQL interfaces. So we do have a lot of different ways to access data. So if you want to access things with like SQL, with machine learning, with Python, with R, like I said, there's a lot of different APIs we offer. And we do offer even things like SQL. Now, SQL doesn't make sense for every single data type. If you're accessing documents, if you want to do vector search with natural language, you probably prefer like a ChatGPT style interface. If you're accessing images, probably not going to run SQL. But the flexibility that TileDB gives you is that you can use the language and the tool and the integration that fits the job that you're trying to perform. So the last thing that I want to show before I stop, because I know we're about out of time, is just one example where we will actually show just in a brief moment how you can actually query TileDB data and how you can use machine learning directly on top of TileDB. So we're going to go back to imaging here, and we're going to actually show using that machine learning model, that edge detection model that we showed earlier, and we're actually going to run it directly here in the TileDB Cloud system. So we'll import a bunch of Python packages, including PyTorch and TileDB ML. It's a variety of helper functions and classes that we've built for machine learning directly. And if we actually preview the image, we can see that this is a picture of a drone image, and it's a picture of a park. And we see some roads, some rocks, some trees as we go here. Now, to actually run the machine learning package, we're going to be using a lot of the same functionality that you might already be familiar with PyTorch or TensorFlow. using PyTorch with TileDB is going to be natural in the exact same way that you've been doing it on your existing data sets today. And that's one important thing that we take very seriously and try to differentiate with TileDB. When we integrate with third-party packages like PyTorch or TensorFlow, we make the integration a native integration that's very tightly coupled. We want the ability for you to use machine learning packages and machine learning models like you normally would, without having to export the data, without having to convert the data. We're simply pointing to the TileDB data set, passing in whatever parameters are relevant, and performing your operation. So here we define things like, the PyTorch device. If you have a GPU, let's use it. If not, fall back to CPUs. TileDB is flexible. The current notebook I'm in is running CPUs only, but we do have the ability to run GPUs if you want. We'll go ahead and define the entire network. This is just an edge detection network. We've got an open source one that we pulled from GitHub available here. So this is nothing really special. This is just showing that you can bring in like a network like you normally would. And then we create an instance of that network. And then to actually store the model in the registry, we have very simple functions: PyTorch, TileDB model, same thing for TensorFlow, sklearn, and others. We just give it a couple things. What name do we want to call it? You saw earlier we've already registered it and called it PyTorch Edge Detection. Who should own it? When you're creating data sets or models or any type of asset, you can define ownership. Is it myself? Is it my organization? What have you? And I just pass in the network instance that I've created here. That's it. Now I have a TileDB wrapped machine learning model. I can save it. I can update it if I want to. We make it very simple. And of course, if I want to load it, we have the same functions where I just give it the URI and call load. And you get a PyTorch model directly back. Now, to actually access the data and query it, again, it's going to be very, very familiar to those that have used PyTorch before. Here, I'll define a helper function where I'm going to open up my image. TileDB supports multi-resolution with multi-channel images, so you can get pretty complex if you want. In this case, it's just a simple drone image, so we have one layer. We'll open up that one resolution of the image, and we'll call the TileDB PyTorch data loader. All I do here is pass it the array. And if you want to do any type of batching or randomization or things like that, you can simply pass those parameters here. But that's it. I don't have to query the data myself. I don't have to convert it to NumPy. I don't have to export it back to an image. We have a PyTorch data loader that understands it. For this example, I set batching, but I'm just going to concat all the batches together for simplicity. And then I'll call my function. And at this point here, what I have is a PyTorch batch. Nothing's actually been read. I haven't pulled the data into memory yet. We just have a PyTorch batch that everything will be accessed lazily as PyTorch wants it. We can then perform a simple function here that will actually take our network, find the shape of the images, and pass all the parameters to that network itself and load it on the device. And so the input here is just the model and the batches that we have from above. And when I actually call this function, call estimate, at this point in time is when we actually load the image. And we actually fetch the data, and PyTorch behind the scenes talks to TileDB without my interaction. And again, authenticated access control autolog to fetch the relevant parts of the data based off batching or any randomization parameters. And then the results are returned here. And if we actually print out the results, we can see a nice outline of all the images, the rocks outline, some of the trees here. We see the road. We can even see some things like a park bench that wasn't quite shown before. So you can run machine learning pipelines directly on TileDB, directly on TileDB data without exporting, without converting. You can have the models in TileDB. You can have the data in TileDB. And of course, you can do all of this in a distributed fashion too. So I can also take my functions that I have above. I can create a task graph. I showed you some registered task graphs earlier and some logs of the task graphs. To actually build the task graph in Python is quite simple. We have a couple different high-level APIs. But here, I'm just going to use our basic direct acyclic graph API. I give it a name. I'm going to run this in batch mode. You have the capabilities of doing things with large asynchronous jobs. We can also run things in real-time mode. So you have capabilities of getting results now or running things to retrieve later. TileDB supports all different operations. Here, I have 18 images. I'm just going to loop over. I'm going to just call submit, dag.submit. I'm going to say edge detection. I'm going to give it my the array, the image URI, resources. If I don't specify resources, we have defaults. If I want to use GPUs or others, this is where I could do it. Also, any Docker images that you'd like to use here. And if we visualize, we can see all 18 from when I kicked this off earlier. And to actually call compute, I just call dag.compute. Now you'll notice here, I specified resources, but I didn't specify that I want a cluster. I didn't say that I want a Spark cluster of 20 nodes, a Dask cluster of 50 nodes. I didn't say I want these resources from Amazon. All I did is define a Python function, some basic resource requirements, and then I call compute. Behind the scenes, TileDB takes care of all of the infrastructure. So TileDB can manage the data, we can manage the machine learning models, we can manage documents, we can manage the code itself. We manage the infrastructure directly in the database, whether that's running large-scale task graphs, whether that's running GPUs, or hosted dashboards. Everything in TileDB can be completely managed by the database. We bring it all into one place with centralized governance and access control, and a centralized place for all users to come to build out your end-to-end use cases and your end-to-end applications. All right, with that, I know we're at time, so I'll go ahead and stop and turn it over for any last questions or thoughts.
Seth, real quick, there are a couple of questions. So I answered one. Dimitris was asking whether the database part of TileDB is modeled after vector databases. It's a valid question, but it's kind of the other way around. TileDB pre-existed vector databases, and also TileDB is more general. It has arrays as first-class citizens, and arrays are general. They're multidimensional. Vectors are one-dimensional. That's the definition of the vector. It's a one-dimensional array. So it was very easy for TileDB to support all the vector database functionality, like the vector embeddings, the indexing, like all the different types of indexing. They're quite simple. They're k-means based. Most of them were graph-based, like Vamana and HNSW. So we built all of that, and it was quite trivial for us to do. But then we inherited everything we built on arrays, like the versioning, time traveling, the object store functionality that we have. So that allowed us to subsume them completely. So right now, there's no reason to have a vectors database and then something else stored in TileDB or others. You get everything in a single place. So that's one on the vector databases. Now, yeah.
Before you go on, for the recording, please also read aloud the questions. So
Yeah.
for this question that you're just about to answer, read the question aloud before you actually say the answer.
Yeah, George, thanks. This is certainly important. So for the first question is quite big, but I'm going to explain and touch upon the biggest things. There's a question around whether if we have any differences to OneDB AI. This is the first time I hear this product, by the way. I don't know if Seth knows it, but there's another question which is perhaps the most relevant thing, which is that's the weight and biases. We discussed about this 1 hour ago over coffee with Seth. So Seth, take it away, since this is exactly the discussion we had an hour ago.
Yeah, thank you. So yeah, the question in verbatim is, what would you say are the main differences with WandDB.ai, weights and biases, as far as the compute module is concerned? Or to put it more simply, can someone replace ML ops software services with TileDB? Our intention is that you can replace the ML ops software completely with TileDB. We provide the compute infrastructure, we provide the model registry, we provide the direct integrations with the TileDB datasets itself. We provide the versioning and tracking of different models, different runs of the pipeline, on all the audit details you need to rerun pipelines directly in TileDB Cloud. So our stance is that we can completely replace weights and biases. Of course, there are some differences between the two software, and the main one that I'll point out is that TileDB integrates directly with the data itself. Right, weights and biases is focused only on the ML side. And you have to bring your own database. You have to bring your own integrations wherever your data is stored, whether it's stored on object stores like images, whether it's Snowflake or Oracle for tabular data. TileDB, we have the integrations with machine learning packages that we maintain at a very low level for the dataset API. So we could do more than just the registry and more than just the compute. We've got the data aspects too. There was a second part of that question, which is for workflow definitions. Do you follow an Airflow-like graph creation process? Can I monitor and create if-then conditions in the graph? Thanks. Yes, we have a lot of support for permutations of the direct acyclic graphs that we support. We follow an Airflow-like or a Argo workflow-like setup. So you can do dynamic graphs, you can have conditionals, you can pass in different parameters. Each stage of the graph is heterogeneous, so you can mix and match the actual tasks, the languages that are used, or the compute environments that are used. So you can have one that has GPU access to run an ML example, pass the output of that directly to a next stage that might be CPU only.
I can take the next one. So if I understood the architecture correctly, TileDB is the dimension index executing a TileDB-owned VMs over S3 object store blobs living in client-owned buckets. Where do the UDFs and pipelines execute? All right, so first of all, TileDB has multiple parts, but all play together in a single database architecture, as we said, right? We're not taking 10 different pieces and we aggregate them together. They're seamlessly integrated. So on the storage engine part, TileDB has its own format. So think of it as Arrow and Parquet. But then the data model is more extended. It's a multi-dimensional array. So it handles tables, but also it handles all the other ND array data types. And it has its own indexes. It has, for example, for the dense arrays, the indexes are kind of metadata based because in a dense array, you can infer where each byte lives, where each cell lives on the disk, just from the schema. But in the sparse case, where you have the majority of the cells empty, then we are using a coordinate format. We're using R3s as indexing. So there's a lot that goes into this. And then in both of them, you have we are following an immutable data storage technique that's how we do the versioning and the time traveling. So there is a lot of sophistication on how to do this, especially on object stores, and a lot of optimization specifically for object stores. So yeah, now that's the storage engine. And this, the majority of this is part of open source. Now, the VMs are, we use Kubernetes for this. So that's TileDB Cloud then. We have all this elastic and serverless engine. And of course, Seth can chime in more on how we use this. But this is where the UDFs work. This is where the task graphs work. We build our own drivers for the task graphs and how we respect the dependencies. So all of this is built from the ground up inside the TileDB Cloud product.
Right. Thanks. Hi. Hi, Stavros. I think I have a vague feeling that we have met somewhere, but I'm not sure. Well, in any case, okay, thanks for your answer. I've been going through the code of the, well, at least of the open source project you have on GitHub. And this is my understanding of this, right? So that the best way or the closest way to think of TileDB is as of a cube in a proprietary format or a TileDB specific format on one place on a bucket, and a different set of structures that index the dimensions of the cube. Right, the R3 files in your source code seem to be pointing to external to them entities, right? So what I was trying to figure out was how do you do the accounting for the processes that execute in your process space then?
So Stasine, what you're reading is the storage engine alone. That's the open source part. So yes, that code handles the open spec format. The index is as part of the format, and the engine to write and read very efficiently from a single machine, because it's a library. It's not a distributed service. TileDB Cloud, the majority of what Seth showed you, is the closed-sourced product that uses this library through and through, but it builds on top a lot, like a catalog. And we have a database of all the customers, a database for the access policies, then the drivers, so the registries for the UDFs, the code, then the whole magic to place specific UDFs to be executed on pods in a Kubernetes cluster. The way we expand the Kubernetes cluster and we shrink it based on demand, then the drivers for the task graphs. All of this is part of the closed-sourced product that Seth showed you. You're not going to find this in the GitHub code.
But still, okay, sure, but still. So the UDFs execute in TileDB process space, right? Not client space.
Exactly. There,
Okay.
it depends. If you use SaaS, let's actually
Yes.
differentiate because it's a good question. So what Seth showed you is SaaS, meaning you go to cloud.tildb.com, you sign up, you sign in, that's it. You don't need to install anything. Everything is done there. The buckets are yours.
Yes.
So when you need to set up some keys or roles once, and that's it. Like you need to give TileDB the ability to write and read from your buckets. And then the data is yours in your buckets, but the compute is TileDB's. So TileDB has 5 clusters around the globe, Kubernetes, scalable. You don't need to think about spinning up anything. So, but whenever you execute the UDF, TileDB Cloud is responsible for finding a pod in the cluster, mounting securely your code, making the accesses, and so on and so forth. So you're right. The buckets are yours. The compute is ours, TileDB's.
Okay.
However,
and the expense of transferring the data that Amazon is charging for?
yes. So I'll tell you in a bit how we do that. You have a second option, which is you take the deployable, it's a Helm chart, get our code, the codes from us, and you set it up wherever you want, your own cloud. So in that case, you pay just the license. The compute is yours. We don't charge. We don't meter the compute.
Yes, of course.
It's fixed. It's predictable. In fact, we work with you to optimize your costs. We don't want to have incentives to charge you on consumption because, again, like then Seth is going to say, but I'm working towards performance. You're going to do less consumption because of my performance. And there are weird dynamics. We don't want to get into this. It's a fixed license, depending on how many people will use it. So we work with you to reduce the overall cost. Even with the license, you reduce your costs, right? Now on SaaS, because we need to be protected from Amazon, we don't want to make money on this because still we're going to give you a subscription. Still we're going to make money out of subscription. However, we need to pass some costs to you because we get charged. There we meter. We meter how much you compute on a CPU second level. So that's fine, great. And we tell you, look, this is how much we get it. We add a little bit of margin, but not 2x, 3x, like a little bit of margin. And that's how we pass the cost to you. And we take it out of the subscription. You see, like, again, it's not our goal to make money from your consumption. We're just going to protect ourselves. So we put a little bit of margin on top, but again, we take it from the subscription so that we don't charge.
Okay. I'm not interested in the business model. I was just asking from a purely technical perspective
SaaS,
how
we meter.
You can make this work.
Yeah.
Because I know that Amazon is going to charge you for the silliest of things, like transferring 5 bytes of data across regions or something. Yes.
Correct. We pass that. We measure it. And we pass that cost to
you pass it on. Okay.
Correct. Unless the user self-hosts. In that case, we do nothing. It's your cost.
But in that case, Okay, I assume that for some of your clients, it also makes sense to self-host because they don't want to show you what processing they're performing.
Exactly. It's a privacy thing, yeah. For us right now, it's 50-50 split.
Yeah. That makes sense. Okay, thank you, Stavros. Thank you, Seth.
No, thank you. These are great questions.
I don't see any other question in the chat, so maybe I can have a question myself. I think I'm very impressed by the variety of different solutions that you support. And I was wondering, what does this mean in terms of customer support? Because you have to deal with very, very different demands, very, very different requirements. And how does this fit with your business model?
Yeah, absolutely. This is an excellent question. Well, the bottom line is we do it a lot. we support our customers a lot, and that's why we work almost exclusively at this point with large organizations. That's the reason, because we want to provide the support. We build an amazing sales engineering team. We don't even call it a support team. It's a sales engineering team, meaning that those are actual engineers that work very closely with our customers. And for high profile customers, even Seth and myself are involved. The good news is that we're producing a lot of materials. We do some upfront training, and then it takes off on its own. So there is a little bit of upfront cost for us, to train people, webinars, you name it. Like we spend a lot of time with our customers, but that's also the value, because then they realize this massive value and they say, okay, we will stick with this product. So thanks for asking this, but consider it granted. Like you engage with us, you're gonna get a ton of support, and we will figure out how to scale. This is our job.
Okay, so I guess there are no more questions. Maybe before we close, Stavros, you can say what are the possibilities for next steps? How did you imagine follow-up or anything like that?
Yeah, absolutely. So we can do a couple of things. The first thing, the easiest, is you guys can go on cloud.tildb.com, set up an account, set up an organization. We will let you do that. Put as many people as possible. We're going to give you free credits. Just play around, and then perhaps we can like the thing that has worked for us the best is we identify a couple of quick use cases where TileDB can bring immediate value, like something that was done slowly or could not be done at all. And then we introduce TileDB and we say, all right, now we will have a quick success for this. And then it's going to be easy. Our goal is to get all of you guys on the platform so you do all your work. But again, because it's so diverse, people may, introduce a little bit of resistance, saying, okay, like we can do everything. All right, let's work on a couple of very important cases where you need to be successful with a new product. And then we take it from there. We can expand later.
Okay.
I can follow up by email on that, by the way.
Great. I think that would work. And we will certainly distribute the video so that other people who would not make it today can see it. And if anyone from the audience has any ideas about case studies that we would like to try, be it at a level of a solution or an experiment, or even at a more fundamental level of trying out a new method, I guess we can discuss with Stavros and Seth.
Sounds great.
I don't know if I can switch on my camera. I'm not allowed to switch on my camera, apparently. Anyway.
Yeah, I tried that too. It doesn't work.
It worked at the beginning, but I think now Faye has locked it for me.
Maybe
so,
only
as you can do now. You can open your camera now.
Okay, great.
There you go. It's you need to be a co-host to do that. Okay.
So thank you both Seth and Stavros for your time and for your interest in presenting to us TileDB. I think it was great for all of us, and I hope we can follow up and try out some new things, possibly for the benefit of both of us.
Sounds great.
Thank you very much and have a good day.
Thank you.
Thank you all.
Bye-bye.